All right, hi folks, this is Larry Maslino. I'm recording a video for Section 3.3. It's on the chain rule. This is another rule for finding derivatives. Now, in the past sections, we've talked about the power rule, the product rule, the quotient rule. The chain rule is going to come into play when we have what's called a composite function. You can think of this as a function of a function. For example, if you look at this function here, capital G of x is the square root of x squared plus 1. You can really imagine this to be two separate functions. One function is the square root function. The other function is the function x squared plus 1. We're taking the square root of the function x squared plus 1. This is a function of a function. When you take a derivative of a function, this is where the chain rule is needed. Okay? So when we're trying to differentiate more complicated composite functions, we need this chain rule. Okay, think of this as a function of a function. You can almost think of this as, if you have an inner function that's just x, then you really don't need the chain rule. Let me give you an example. If I have f of x equals x to the 6. Notice I'm putting an x inside parentheses. If I just have an x inside a parenthesis, I'm not going to need the chain rule. I'll give you another example. What if I put the function x squared plus 1 being raised to the 6? Notice what's inside the parentheses is more complicated than just plain old x. This is where we're going to need the chain rule. Okay, so we're going to think of this as taking as a function where we have an inner function and an outer function. This x squared plus 1 would be the inner function, and raising to the exponent 6 would be considered the outer function. All right, so go to the next slide. Again, going back to this example of the square root of x squared plus 1. Here you could think of the inner function as x squared plus 1. The outer function would be that square root function. So again, we have an outer and an inner function. This is where the chain rule is going to be needed. Let me show you some examples of where the chain rule is not needed. That's the left side of the slide. Then the right side is going to be examples where the chain rule is needed. Notice on the left side, these examples only have the plain x inside the parentheses. When that happens, the chain rule is not needed. Let me go over to the right-hand side. Notice inside the parenthesis here is x squared plus 3. Inside the parenthesis here is x to the third plus 2x squared. Inside the parenthesis here is square root of x. Again, you can think of this as an inner function and an outer function. Here, these examples are where the chain rule would be needed. All right, so how do you use the chain rule? Here's what the chain rule says. It says if you have an outer and an inner function, here we're calling the outer function g of x, the inner function is f of x. What you do is you first take the derivative of the outer function, but notice we're leaving f of x alone as the inner function. So really we're just taking the derivative of the outer function. But then I have to multiply separately by the derivative of the inner function. This is why it's called a chain rule. You're kind of chaining on this derivative of the inner function. Okay, so think about it as the outer function and then the inner function. And then when you take a derivative, you're going to take the derivative of the outer and multiply it by the derivative of the inner. Okay, let's talk about a specific example when we might be taking a function raised to an exponent. Let's do an example. Let's say I'm taking the derivative of, let's say, x squared plus 6x being raised to the exponent 8, let's say. All right, so what I'm thinking about is this function inside, according to this notation, we would call what's inside the parenthesis f of x. So let me call this x squared plus 6x function f of x. And of course I can see our n here is matching up to 8. So our n is 8. All right, let me go ahead and plug in to the right-hand side of this template. All right, so it says bring the 8 down in front as a multiplier. Then notice it says leave f of x alone inside the parenthesis. So I'm going to write x squared plus 6x. Then I'm noticing I have to decrease the exponent by 1. This is the power rule. 8 minus 1 is 7. But then notice, here's the important part of the chain rule. I've got to multiply by the derivative of what was inside. Our f of x here was x squared plus 6x. So I have to take the derivative of that function. So I'm going to multiply by 2x plus 6. That's the derivative of x squared plus 6x. Okay, let's do some more examples of the chain rule just to see some worked out applications. Okay, let me jump ahead to, let's do this example. Here's a function, and it says take the derivative using the chain rule. Let me go to the next slide. So I'm bringing that exponent 2 down in front, leaving f of x alone, subtracting 1 from the exponent, so 2 subtract 1 is 1. Then the chain rule says I have to take the derivative of what was inside the parenthesis. The derivative of that f of x function, the derivative of 3x plus 1, that's just 3. So you can see I end up with this result as the derivative function. So you have to remember to take the derivative of what's inside. All right, let's do an example here. Again, I know I need to use the chain rule here because I'm noticing a function being raised to another function. You know, if the function here was just plain old x to the 4, I wouldn't need the chain rule because I would just use the power rule. But it's a more complicated function being raised to the exponent 4. All right, so let's take the derivative. Well, this 5 is just a constant, so I'm just going to carry that down with me. Now let me take the derivative of x to the 3rd minus x to the 4. Okay, according to this chain rule, I'm going to bring the 4 down in front. I'm leaving that f of x function as is inside the parenthesis. That's this part. I'm going to subtract 1 from the exponent. That makes it 3. And I can't forget that I have to multiply times the derivative of what's inside. So the derivative of what's inside the parenthesis is 3x squared minus 1. Okay, so that was the chain rule. Let's do another example. Okay, let's do the top example. Again, I'm going to bring the 8 down with me because that's just a constant. This exponent 5 comes down in front as a multiplier. I'm going to leave the parentheses as is, subtract 1 from the exponent, so the 5 goes to a 4. Now the chain rule says I have to multiply by the derivative of what's inside the parenthesis. The derivative of t to the 3rd is 3t squared. And of course, the derivative of that constant 2 is just 0. So I end up with this result for the derivative. All right, let me go to the bottom example. The bottom example is very similar to what we just did. The only difference is it's a negative exponent, but that really doesn't matter. I'm going to follow the exact same procedure. This 1/2 is a constant in front, so I'm just going to bring that down with me. I'm going to bring the exponent -3 down in front as a multiplier. Copy down the function in parentheses, so I'm just copying down 8t squared plus t. Subtract 1 from the exponent, but -3 subtract 1 is a -4. Now the chain rule says I have to take the derivative of what's inside the parentheses. Well, the derivative of 8t squared plus t is 16t plus 1. Okay, so this is the chain rule. First, you have to recognize when you need the chain rule. So anytime you're taking a function of another function, or the derivative of a composite function, the chain rule is To the bottom example here. So the bottom example, I'm going to think first. I'm going to do for the bottom example is to rewrite this using fractional exponents. So I'm going to write this as 10t squared minus t to the 1/2. I haven't taken any derivatives yet. I'm just rewriting the original function using the exponent 1/2 instead of using the square root symbol. Now let me go ahead and take the derivative. All right, I'm going to follow the instructions for the chain rule. Okay, it says take that exponent 1/2, bring it down in front as a multiplier. Then I'm going to subtract 1 from that exponent. Notice I'm copying the original function down as is. So I'm not doing anything to that parenthesis. I'm going to subtract 1 from the exponent. 1/2 subtract 1 is negative 1/2. Now I have to take the derivative of what's inside. The derivative of what's inside the parenthesis, 10t squared becomes 20t. And then the derivative of that t is just 1. So 20t subtract 1. Okay, let's do one more example on the next slide. All right. Now, there's a couple of ways I can proceed for number 7 here. And number 8, for that matter. I could think of this as the quotient rule and take the derivative using the quotient rule. But it's actually a little simpler because the numerator here is just a constant. Turns out it's going to be simpler to rewrite these fractions by taking the denominator and moving the denominator up to the top. All right, so let's go ahead and do that. Let me rewrite the original function then, where I'm going to take the denominator and move it up to the top. What that does then is changes the exponent from a positive 4 to a negative 4. Now I can take the derivative using the chain rule. Okay, well, I'm going to bring this 4 down as a constant, so that just comes down with me. Now, let me go ahead and take the derivative. This negative 4 comes down in front as a multiplier. I keep the parentheses the same. That's the original f of x. Subtract 1 from the exponent. That gets me a negative 5. The chain rule says I have to take the derivative of what's inside the parenthesis. The derivative of what's inside is 2x. Of course, you could simplify that if you'd like. All right, let's go ahead and do the bottom example. All right, so let me rewrite this function here for problem 8 with the same process as we just discussed. I'm going to take that denominator and bring it up to the numerator. In the denominator, it would have been the exponent 1/2, but because I'm bringing it up to the numerator, it's going to flip to be negative 1/2. Now I can take the derivative using the chain rule. So let me bring the 7 down with me because that's a constant. This negative 1/2 comes in front as a multiplier. I copy down f of x, that's 2x squared minus 1. I have to subtract 1 from the exponent. Negative 1/2 subtract 1 is negative 3/2. And then here I have to multiply by the derivative of what's inside. The derivative of 2x squared minus 1 is just 4x. Of course, I could simplify the answer a little bit. I'll let you do that, but this is the chain rule. All right, let me know if you have any questions as you're working in section 3.3.